Hi everybody, so today we're going to start a new interesting topic, inequalities. What are inequalities? Inequalities, basically a mathematical sentence just like an equation, except it contains these four signs. What are these four signs? Well, the first one is the less than sign. The next one is the greater than sign. The next one is the less than or equal to sign, and the following is the greater than or equal to sign. The ones that have the or equal to, also have that little line underneath, just like an equal sign. There are many ways that people try and remember which one is less than and greater than. I think the best way is that the one with an L for less than kind of looks like an L in the way that it's facing. That's my way for remembering it. Also, that it's pointing towards the smaller side. People have all these different ways. Either way, after practice, you'll definitely get used to which one it is. Next word we need to know is the solution set. The solution set is the set of all solutions, because when working with inequalities, you're going to have more than one solution. It's not just going to be that x equals 2, or perhaps x equals plus or minus 2 when solving for absolute value, which we'll talk about later. There's going to be a wide range of solutions in a solution set. So, how do we determine if something is a solution? First of all, here we have our rules box. This time we're going to call it our steps box. Step 1, substitute the value. We already know how to substitute. Great. Step 2, simplify for both sides. And then step 3, determine if true. Here are our few examples. Example 1, 2x minus 4, is it, question mark, greater than or equal to negative 4? Well, let's find out. We're going to substitute 2 in for x. 2 times 2 minus 4. Is it greater than or equal to negative 4? Well, then we have 4 minus 4, which is 0. Is greater than or equal to negative 4. This is true. So yes, 2 is a solution. Next one. 3. We're going to substitute in 4 for y. So 3 times 4 minus 7. Is it, question mark, less than 2? 12 minus 7 equals 5. Less than 2? No, this is false. So therefore, 4 is not a solution. 5 is not less than 2. Let's give this a shot. Let's try our own. So we're going to substitute 4 in for x. So 2 times it by 4 minus 2. Is it greater than or equal to 3? Let's see. 8 minus 2 greater than or equal to 3. 6 is indeed greater than or equal to 3. So this is true. Great, let's keep going. We're going to substitute in negative 1 for y to figure out if this is true. 4 times negative 1 minus 2, less than 3. So now we have negative 4 minus 2, less than 3. Negative 6 is indeed less than 3. So this is also true. Fantastic. Number 3. Oh, we have 2 things on each side here, so we're going to have to put 2 in here and 2 in here. 5 times 2 plus 3, is it less than or equal to 2 times 2 minus 4? This all together is equal to 10 plus 3, less than or equal to 4 minus 4. 13 less than or equal to 0? No, it is not. This is false. 2 is not a solution. 2, not a solution. Let's keep going. 4 is going to have to go in for W there and there to figure out if this is true. So 4 times 4 plus 1. Is it greater than 8 times 4 minus 2? We have 16 plus 1 on this side, greater than 32 minus 2. 17 greater than 30? No, this is false. So 4 is not a solution. Great. Let us keep going. Now we're going to have to learn how to graph. These are our graphing symbols. Just like we had the line underneath the symbols, this was our or equal to sign. Whenever we have the or equal to, we have to fill in the circle when graphing. As you can see, When it's not or equal, we leave it hollow, or open as they like to call it. So let's look at some examples. X is greater than or equal to 2. So we find the point where 2 is at. Then we color in the circle. It is a closed circle, as they call it. And we point it to the right because all of the solutions greater than it are included in this set. Next, we have X less than 3. We're going to leave it an open circle. Because it's not equal to 3, it excludes the value of 3 in the solution set, or then we're going to point it left, because anything less than 3 is included in our solution set. So let's give this a shot. X is greater than 3. It does not include 3 in the value, so this is an open circle. Then it's greater, so it includes everything to the right of it, every value greater than 3, but not including 3, hence the open circle, is included. Next, X is less than or equal to 5. Negative 5. It includes the value of negative 5, so that is a closed circle, and then it includes everything less than it, so we're going to go to the left to include all of these values smaller than negative 5. Fantastic. The last thing we're going to do today is to learn how to solve these inequalities. So we basically generally solve it just like solving a regular equation with the adding and subtracting before the multiplication and division, with one exception. When multiplying or dividing by a negative number, you flip the sign. This is important, flipping the sign when it's a negative number that you're multiplying or dividing by. So let's give it a shot. Here, what we did was we subtracted 7 on each side, evidently, to get to negative 5 is greater than or equal to X. This is our solution, and we graph it. Closed circle, because it includes 5 and it goes to the right. Next example. So we add first. Then we have negative 3x is less than 6. We have to divide by negative 3 to isolate x, so we flip the sign. The signs are flipped from a negative to a greater than. Then we're going to graph it. X is greater than negative 2. Open circle, because it excludes the value of 2 pointed to the right because it's greater than. Let's try our own examples. First, we're going to add plus 1 on each side. 4 is less than or equal to 2x. Divide each side by 2. Add each side by 2. 2 is less than or equal to x. We can rewrite this as we're used to, as x is greater than or equal to 2. Just remember which side is pointing which way. It's pointing towards a 2. It's pointing towards a 2 here as well. Towards a 2. Towards a 2. Let's get rid of that. So now, x is greater than 2. So we are going to have, here it is, filled in. Then we're going to have a closed circle and point it to the right for every value greater than 2. Now let's go over here. We're going to subtract by 2 on each side. Negative 4x is greater than or equal to 4. Divided by negative 4. Oh, here we go, dividing by a negative number. So now we have x. We're going to switch the sign. Is less than or equal to. We've switched the sign because we divided by a negative number. Negative 1. Great. Closed circle, because we are including the value of 1 and we are going left. All the values smaller than it are part of the solution set. Fantastic. So this was our course on basic inequalities. The next course will be about compound inequalities. Stay tuned.